Hello, welcome to another video of this SVA Design YouTube channel. I'm Shaquille Veldboom, and in this video I wanted to take you guys along with just an experiment that I'm doing with this car setup. And this is a software program called Algodoo, and it's basically just a physics engine basically, but in 2D. So you will probably be used to me putting up videos of just 3D SolidWorks stuff, but this is a different software setup, and yeah, so it's basically just a physics engine. So you can have just this car suspension setup, and yeah, you can see this bouncing around, and you can turn these axles on the wheels, you can turn them basically into engines and everything. So it's not really a car representative engine because it is very linear. So through every single RPM it will be putting out an equal amount of power directly to the ground, and that is just basically how everything is. So what you can see, but what I will show you right now, is that I've also made these two plots on just in Excel, and I will be just do some data logging and just to basically show the difference in acceleration and braking with different suspension setups. So as you can see right here on this car, there is just this main body of the car, and I'm actually thinking about maybe adding on to a little bit of the body so that it's just more clearly how the weight transfer on the car is just working and everything. So let's do that. So yeah, I hope this bar will kind of make it a little bit more clear how the weight transfer and everything will work on the car, and because that will basically be a very determining factor on the acceleration and the deceleration in these different configurations. And the reason why I'm doing this test is because I am designing a car, insert picture right now, and I've developed a pretty sophisticated suspension setup that will be variable in a lot of different ways, and also it will adapt very quickly to its situation. So that was basically why I'm trying to kind of configure for different situations for the car, different suspension setups that will work in those situations. So that is basically the purpose of this experiment. So first things first, I wanted to start off with just a pretty low ride height and some pretty stiff, just a pretty stiff suspension setup. Through this whole test, the weight of the car will stay the same, the weight balance and everything will stay the same. The only thing that will kind of change, and yeah, just the only thing that will be variable will be the length of the suspension and the damping of the suspension, and also front to back. Just the changes in suspension setup on the front wheel and on the rear wheel. So that is basically the only thing. So right now we will start with like a base setup, and both the front and the rear of the car will be equal in just the ride height and everything. So right now it's 13 Newton meters and it is 1.15 meters long. So front and rear will be 1.15 over 1300. So I will just put it in the Excel sheet, and we will be continuing on. So the second thing that you can do in Algodoo is just select a component and select show plot, and this plot will basically show you how fast it is traveling and in meters per second, and yeah, so you can, and also show like acceleration times and just all of those things. So in this Excel sheet that I made, I'll have some measurement points on 10 meters a second, 20 meters a second, 30 meters a second, and 40 meters a second. And what I will the thing that I will write down will be the acceleration time. So it will be something around like 4.7 or maybe like 5 meters per second of acceleration. Meters per second every second that will be added to the total speed. So at every single milestone we will be taking a data, and with the same suspension setup we will also be doing the braking, and we will kind of look at it in slow motion, and we will yeah, just look at it in slow motion and see how this weight transfer works on the braking and during acceleration. So that is basically the setup of everything and how we will be doing this. And afterwards we will kind of analyze the data, and we will be yeah, just analyze the data, see what we have learned, and continue from there now. So if that sounds good, continue watching the video. If this sounds boring to you and just sounds like just me geeking around, which it is, then you can enjoy some other speed art videos on the channel. So let's start off. So yeah, on this axle right here, you can if you have an axle, you can just select like forward key. So this is a right key now, then we'll start to move in that direction, and brake key is down. So on my car setup, because the car that I'm designing will be a rear wheel drive car, I've only put an engine on the rear tire, and this tire will do braking, and this one will do braking as well. So that's basically the setup that I'm working with. And the braking power, by the way, is 50-50, so there will be equal braking between the two of them. So yeah, that's everything. So right now I can say like hit the gas and it will start moving, and you can see that it is moving along. Not a lot of weight transfer happening. This bar is still it is tilted back a little bit, and now the car stops accelerating and everything is leveled out. So okay, what we can do now is go to this line, and as soon as we reach 10 meters a second right here, you can see that there is a measurement point of 4.802. Those are our first measurements, and now we can again start it off and yeah, now do the braking test. And no, you can see the weight transfer now happening, going towards the front, and the tires immediately locked up. So that is the first car, and we should just probably look at some slow-mo footage of everything that we've done so far. So if we let's first of all start with the acceleration phase. So what we can do is then slow up everything in the system, and we slow up everything by about 10 seconds. So if you can look at just everything that we're doing right now, we're just going to look at the body movement of the car, and if you could see something that is maybe off a little bit, and what we could change through to the suspension setup and everything. So that is basically what we're looking for. So here we go. So we can see that initial weight transfer happening pretty quickly, and then it just stays very similar on the same line, and we have continuous wheel spin throughout the whole acceleration phase basically. So that's what you can see initially, and you will see probably when we kind of raise the car a little bit more and soften the suspension that the body will just tilt back way more aggressively, putting way more load on that rear tire and having less wheel spin. So that is one of the things that you could probably expect that will happen. So we can now go back and kind of look at the deceleration phase, brake. So you can see the tires immediately lock up, and just that initial car dive movement. And yeah, that's basically what happens. So if you have ever been in a car, you will feel that the car is trying to just continue to move, just move in that forward direction, and the energy gets transmitted directly into the ground. So that's basically what you could expect. Okay, so next setup. So I personally think that if we would, let's say we keep the front the same, but we kind of raise the rear and also make it softer to help that initial launch for the weight transfer to occur. So that is the next thing that I will do. So we'll make it softer, so let's say instead of 1300 put it at 750, and you kind of see the car dip immediately, but we make this way longer, so let's just raise it that you can kind of see it, 150. So the front stays the same, but in the rear it is 750. It is 1.5 over 750, so 1.5 over 750, and the front stays the same. Okay, now here we go. Let's see what happens. I think you could slightly see the body move a little bit more. Look at the Excel sheet, you can kind of see that this one is an increase in speed, this one is an increase in speed, this one as well, and here it drops off a little bit more. And why that is probably is because as soon as the car is at speed, it would probably be better if it had stiffer suspension to keep that platform as stable as possible to keep putting the power down. But for the initial launch, you kind of need a softer suspension setup to cope with the extra weight transfer to help the car from having less spin, so having less wheel spin. That's the word I was looking for. So that is basically the difference between the stiff suspension setup and the softer suspension setup on the rear. So next up, the braking phase. So let's see what happens. Okay, so the car is at standstill. See if you can see a difference. 5, 1, 4. Okay, so if you then look at the deceleration graph, you can now see that this first step is 0.3 of a second quicker, which is a pretty big movement, and we will see probably in the slow motion what that is. So in the second chart, you can kind of see that there's still somewhat of improvement, but it's not as significant as it is right here. Third one, this one even beats it, so it's quicker off, so it's decelerating quicker with the softer suspension, and here they're pretty much the same. So we'll see what is kind of making a difference. So if you go back to the initial acceleration and do that in slow motion, so see what that looks like and what kind of weight transfer we can see with the car kind of dipping. So let's see. So that is probably the main thing that you can see. So it is that this black bar is almost level, perfectly level, and yeah, so that weight transfer is way more aggressive. With the softer suspension setup, still have wheel spin, and it just stays the same throughout the rest of the acceleration phase probably. So it's just that weight transfer initially, so that is basically what gives the difference of the line and just continues it throughout the whole acceleration phase. So if you higher the center of mass of the car, it will also be easier for the car to kind of have this weight transferring moment occurring on that rear axle during the acceleration phase and also during the deceleration phase. So that kind of explains both of them. So okay, so now the deceleration phase. Okay, so we can see pretty clearly that this black bar is really diving down now, and of course it initially before the deceleration phase it already was, because we have kind of raised the rear without raising the front. So that whole weight transfer moment is being really not put on the front axle because we also raised the rear, so that really explains that initial deceleration bump that we're seeing in our graph. So yeah, that pretty much explains everything. So because the rest of them were pretty equal, so we'll see what happens with the deceleration if yeah, just during the rest of the phase. So here it kind of bounces back and probably throughout, and it's kind of still moving a little bit but not a lot, but it's just that initial bite that is really killing the previous configuration on the braking. So that's basically just everything. Just the weight transfer. Just put lots more weight on that front side that is doing most of the braking work. So that is everything that we needed to know for this second setup. The third one, let's also raise the front, so we kind of get the same situation as with the rear tire. So we move to a spring that is 1.5. But we kind of make the damping a little bit softer at 750. So now we have an equal suspension setup front to rear, and I think that with this equal suspension setup, with also bracing the front, I think that weight transfer on the rear will be even more extreme because you raise the center of mass. And I think with a softer suspension setup on the front, it will also really allow that front wheel to get kind of lifted up off the air and putting all the mass on the rear tire. So we will see what happens. So here we go. You can see that that black bar is tilted backwards. And throughout the whole phase of the acceleration, you could see that the complete car body was lifted up in the air. So I think we will see some improvements right now. You can see that just all around it is better everywhere. And yeah, I just think with raising the center of mass that much more and also softening up the suspension, you kind of detach that car from the rest of the weight of the body, so it doesn't really, you can't really see it as one part of the body. So it gets easier for that weight transfer to happen because you don't really have to lift the weight of that tire with the complete car, if that makes any sense. So that it doesn't become part of the complete mass of the car body. It kind of detaches from it with the softer suspension setup. So that is also one thing that we can see happening in this scenario. Okay. Braking phase. Here we go. Done. Okay. Okay, so during the braking phase, you can kind of see that that initial bite of the second one is lost because on the second one it was really tilted towards the front of the car. And all that weight was also really leaning on that front tire. So as soon as she hit the brakes, it kind of dived down even further, and that the whole weight transfer occurred towards the front of the tire, towards the front tire, and that would kind of result into optimal braking situation. So because the car is now at a level playing field, that really we kind of lost that benefit because of that. In the second phase, they are pretty much equal, but there's still a slight advantage of the softer, the car diving down on the second one, and on the third one, this one is kind of taking it over again. But I don't really know why that is, but probably it's just a momentum thing that the car is kind of deviating with a softer suspension setup. It is kind of diving down, bouncing back up, diving down, bouncing back up. So that is kind of a moment that could be created in a situation like that. And the last one is kind of equal to the other two, because probably as soon as the car settles down and it stops kind of bouncing around a little bit, and with the tire kind of constantly locking up, I don't think we'll be seeing any differences in this last braking phase throughout everything. So yeah, we'll just check out how that goes. Okay, so I think it's now time to kind of lift this tire up in the air and maybe just drop this one down. So kind of see how that works if we have the front raised in the air and the rear kind of dipped down. So let's just see what that does. So ready to go. Here we go. That looks promising. Let's see. So again, if we could just take that flat again, so you can now you can see that it is still pretty good in acceleration wise, but it's not what it could be with the higher suspension setup all around. But it's still pretty good, but it's not just what it could be. So this is still the winner during the acceleration. with just the high overall suspension setup with the soft damping, and this is the winner in the braking zone. So with the low front ride height and the high rear ride height in the whole suspension, yeah, in that whole setup. And this first iteration is the winner when it comes to high speed acceleration still. So just running the car at high speed, you would want the complete car to be very low, very stiff. So that all kind of makes sense if you look at the data. So what I would try now is go basically repeat this whole process, but do it in a different way with just softer suspension setup. So just trying to find that ultimate setup, because for acceleration and deceleration in a straight line, you basically want weight transfer to occur to the front axle during braking, to the rear axle during acceleration. So that's what we're trying to look for now. So yeah, we will just raise everything, but make the springs way softer. So let's put everything at 170. But put the spring at like maybe 450. And do the same for the front. You know what, maybe let's even go higher than that. Let's say 185. Okay, so that is basically what we're doing for the acceleration. And then on the next one I will probably just lower the front but keep the same suspension, stiffness and everything. So I went 1.85 over 450. High suspension with just very soft suspension tuning. So here we go, let's see what that does. Okay, so that is too extreme for the system to handle. Yeah, let's just keep it at that 170, 450, and do the same thing here. I want it higher still though. So 170, but let's say 650. So we did 170 with 600. Let's see what happens. That was pretty cool to see. Just at the moment where the car stopped accelerating, when it reaches top speed, you can see that the whole car body dropped. So that means that all of the weight was kind of leaning in the air on that right rear tire. So I think this would be a winner. But first, let's look at these slow motion videos before we begin. Okay, so we're gonna just slow everything down again at 10% speed. At 10 times slower than reality, so go. That weight transfer is crazy. But the next thing you will see, and what kind of already started, is not only is that car, that rear of the car is really dropping down, but also the front is moving up. So let's see if we can see it in the next phase. So that whole car body is just lifted in the air. And all that weight right here is kind of leaning back at the same time, so just that weight transfer moment becomes way greater. But I also feel like it maybe take a little bit of pressure off that rear tire, but in the data it shows that it's way better this way, so it probably doesn't. So yeah, that's a cool thing to see. And in that braking period, let's see what happens. weight transfer completely going through the front tire. And it just kind of stays that way. But in that last phase of braking, I thought it was pretty cool to see how when the car just is about to come to a stop, when it stops decelerating, how it just completely lifts again, or lowers again. You can see it drop down. So yeah, that was kind of cool. So that is basically yeah, everything for this suspension setup. So for the last suspension setup that I'm doing, yeah, let's try to find an optimum braking setup. So I think if you just lower this part right here, keep the rear the same, but also keep the suspension setup the same with the damper, I think that weight transfer that could really dive down if you just keep the suspension soft as possible. So let's say 140 over 600 on the front and keep the rear the same. So let's see what happens during acceleration and also then later on during the braking. You don't really see any weight transfer happening in the acceleration process because this black bar still dive down. And let's still take this data down. It is still pretty good. 5.20. 5.204. Next point. Five. 4.889. So that is a pretty big drop from the previous one. 4.9. So braking setup, let's look at that one. And here we go for the brakes. Okay. So, I think we can kind of draw a final conclusion from this whole suspension thing. We can, again, maybe like some color skills. So let's do that. So to compare everything, so now with this color grading you can kind of see the differences, and one thing is clear overall is that this is the biggest winner when it comes to acceleration. So and the reason why you can kind of see it is the highest setup with the softest suspension, and that kind of leads to a high center of mass and a lot of suspension movement, so that the car can that wheel spin momentum will kind of be transferred into a sort of a weight transfer momentum in the complete car body, and that will be transferred again towards more pressure on that rear tire to transform that wheel spin into actual movement. So that is basically the best conclusion that I can come up with this suspension setup. With the braking, you kind of see that it's a little bit all over the place, and everything that's green is the best braking and everything that's red is the worst. So you can kind of see that this final suspension setup that I came up with is very good in the initial braking zone. It is basically the worst of everything in the second braking zone, and again it's the best one right here, and here it is kind of very similar to the rest of them, even though it kind of looks to be that these are better, but if you look at it, it's just like a thousandth of a second. So 100th of a second. So yeah, that is basically everything that it is between those. So I would still say that this is the best braking setup. If you would just take it, well, you know what? Let's take averages. Let's just do that. So if you would take the averages, you can kind of still see that this one is performing good and this one is performing good, and they're pretty much the same thing. So yeah, it's really, and you can also see that there's a pretty big similarity between the two, and the similarity is that they both have a lower front. This one. They both have a lower front than a rear. So you can see that this is at 115 and this is at 1.5, and this is at 1.4. This is at 1.7. And they both have also have softer suspension setups at the rear, at least, and they both have lower suspension, softer suspension setup at the rear, and pretty stiff suspension at the front for this one at least. So maybe it's even worth it to do a final one with a stiff suspension setup at the front. So let's just quickly do that, and we don't really have to look at the slow motion shots, but let's just kind of figure out how that looks. So instead of 600, let's make it again at 1300, but now we will just lower it even further, again to that 1.15, I guess, but with the softer rear suspension. So let's just see what happens in the braking zone, because we can already see that it won't really affect the acceleration too much. So yeah, let's see. So we can now analyze that data, and we can kind of see all the results that we have. So first off, the first suspension setup was kind of, if you just look at acceleration, if you also look at the average number, it was the worst of all of them. And the reason being, it was very low to the ground, very stiff, and this setup kind of doesn't help for that weight transfer to occur. And that's basically all that you want during acceleration period, is just weight to transfer to the wheels that are putting the power down to the ground. So that is that couldn't happen during that first initial braking accelerating test that I ran with this setup. And the second one, it was a little bit better because we kind of raised. No, we didn't raise any. Yeah, we raised the rear tire, and we also made the suspension setup softer, so that the rear tire could dip a little bit more, put more pressure on that rear tire, and so on. So it was a little bit better. The third one was actually pretty good, and this was because we raised everything, and so this means that there was the center of mass was pretty high, and the center of mass could transfer to that rear tire when it started to rotate, and yeah, you could put a lot of pressure down. So, and the fourth one we tried wasn't good for acceleration because the rear tire was lower and was also stiffer, so it couldn't really dip that much. The front stayed up the entire time, so that was a little bit better for the suspension, but it didn't really perform optimum. It is still performed better than these two, because that weight was more transferred to the rear of the car, so it still outperformed these two. But until this point, this one with just the high center of mass is still the better option. This one is the best one we had today with this suspension setup, and you can see that it's just all around very high in of the ground with a very soft suspension setup that would help that weight transfer to initially really bite and just allow that tire to be pressed down into the tarmac and maximum grip, maximum everything. So that is basically what happened in this acceleration phase. So in this one we try to lower the front of the car but keep the suspension just as soft as this one, so we took 30 centimeters out of it, and the rear kind of stayed the same, but there was more to kind of check out what would happen on the front. And yeah, the acceleration, it didn't really help it, and so you can see that it is worse than this one, because you kind of lowered the center of mass and you kind of put a lot of that weight on the front tire by letting it lean forward. So even though that initial launch was still pretty good, because that rear suspension was so soft that it could still allow some weight transfer to happen, but as soon as it kind of lifted up again, you can kind of see that it is pretty bad throughout the rest of the whole phase, and that is really being outperformed by this one right here. So and I feel like this one is the wrong way around. Yeah, that looks more like it should. So it's being outperformed by that one right there. So, and on the final one, this was kind of to try to find the optimum braking zone, and so this wasn't really meant for acceleration, but because it is rear tire setup, it still had a better launch than the rest of these, but these two still beat it. So yeah, if you now go back to the braking performance, then the last one that we tried with the stiff front suspension and the soft rear suspension was the best one of all of them in the first phase. In the second phase, for some reason, it was the worst of all of them. I really don't know what made that happen, and to kind of get a good test, I would kind of want to do it again and get averages, and I think that will kind of balance out, and I think this one will still be the better performing one of all of them. So it might be worth to do that, but for the sake of the video, I'm gonna just keep on going from this point out forward. And you can also see that with other best ones so far, that it also has a point where it kind of drops in braking performance. And I think this is because this weight transferring and just this soft suspension setup will kind of allow the car to bounce during braking and also accelerating. And this bounce will kind of take pressure off the tire, on the tire, off the tire, on the tire, and I think that is what causing this effect to happen, where it kind of outperforms sometimes and just underperforms other times. So I don't know how reliable these test results really are. So that is basically the conclusion that we can come up with. On the braking, you want a car that is lower in the front, higher in the rear, with soft front suspension, soft rear suspension, and let that body roll really occur and that weight transfer really occur on the front axle of the car to maximize stopping performance. And when accelerating, you want the exact opposite. You want just overall higher car with a high center of mass and just very soft suspension, and let that body roll really occur nicely, and just get that optimum launch with that weight transfer occurring to the rear axle. So that is basically the conclusion for this video. If you look at the car that I have right now, insert picture of the car, you'll kind of see that it's a very low setup. And why would anyone design a car that is very low if you can now see these results? This is good for accelerating. This is very bad for and this is good for accelerating and braking. It's very bad for cornering, because you don't want weight transfer during cornering. You want equal weight distribution on all four tires during cornering to get maximum cornering speeds. That is the main difference between accelerating and cornering. So that is also why I designed the suspension setup the way I did, that you can have adaptive systems that as soon as you tell the car that we want to launch now, we're drag racing or whatever, that it could really outperform by raising the entire car, making everything softer, so on and so forth. And again, during braking, do the same thing, lower the front of the car, raising the rear of the car, softening the whole suspension. But then when you tell the car, you put some steering input in, and it will just lower the entire car, make everything stiffer, and give you the optimum weight distribution across all four tires in a steering situation. So that's basically the purpose of these suspension setups, to adapt to any situation and put all the grip where it needs to be in that environment, in that situation for the car. So that is basically why I'm doing these tests, and it's just learning, bro. So that's basically all it comes down to. Sorry this was one of the more boring videos, but I think it's a very informative video, and yeah, I will be doing another one of these. I will probably do another one of these of cornering, and at the same time, the third video will probably be just me explaining everything on the car, suspension wise, and yeah, because I haven't really shown the car in this video. So that is probably be the third video of this series. So thanks for watching. Please leave a like and also subscribe to this YouTube channel if you enjoy this content, and if you're a car nerd like I am. And yeah, stay tuned for more content. I'm Shaquille Veldboom, SVA Design. I'm out.